Hey guys, welcome. It's bright morning here in San Diego, and we're about ready to get going with our Netops Coding 101 tutorial. Trying to keep it mostly on time here for the beginning of the day. This is usually a pretty popular talk, so I'm sure people will show up, so make sure to let them slide by, get their laptops in. This is usually pretty full for that. And anyway, I want to introduce David. David's going to take it away and let us find out all kinds of things they're doing to automate.
Cool. Thank you. Thank you. So in the back, we've got people handing out these USB keys. If you haven't gotten one yet, go ahead and raise your hand. We want to make sure that you do get one. We're going to be using these throughout today for a handful of lab activities and tutorials. We've got, Brandon and all that. Cool. But good morning and welcome. My name is David Swafford. I'm with Facebook NetEng, and today we're going to be looking at a tutorial called Netops Coding 101, which I put this together because we've been talking over the last few years about this thing called FBAR that we use at Facebook, which is our system for handling more of the day-to-day and the automation of things that would normally distract us and take our time. And it's one of the big things that we keep hearing back from feedback from this is, why haven't you given out FBAR? Why is it not an open source? Just do that already. And one of the problems we ran into was that it was just so tightly interconnected with all the systems at Facebook that it's become nearly impossible to give out without giving out everything. So indirectly, what we're trying to do is build FBAR live through these tutorials, both today's 101 tutorial and continuing on that with tomorrow's 201 tutorial, and then over time building more and more. So today is Netops Coding 101, where we're going to be focusing on building your first robot. And taking a look at what we're going to accomplish today, we're going to be looking at automating the remediation and detection of network faults. Things common in your network, such as link flaps and linecard failures. Trying to write software to kind of handle these issues, to do the initial troubleshooting so that you can free up that 5 or 10 minutes that you might otherwise have spent logging into a network device and running maybe some show commands or thinking about what's going on to let you do some more useful things with your time. So today we're going to be building this, though, based on the parsing of syslog messages. So that way we can show you an idea that will work with standard network infrastructure. Now, granted, you might have heard we have these things called FBOSS devices at Facebook, but that's not our entire network. We still use plenty of vendor-neutral and vendor-platform devices, and we find that syslog is one way that we can kind of guarantee that all the devices at least speak the same manner. So today, though, we're going to be focusing on specifically writing code in Python. This will be a beginner-focused tutorial. I do apologize if it's a little too beginner, but I hope that our deep dive into regular expressions at least gives you something to follow with. But we will be starting off basic, but from a network engineer's mindset today. And we're going to be looking at interacting with network devices through software. Trying to write software to do things that you normally would do, to just save yourself some time and to kind of automate these workflows that you're just used to doing. And the meat of our topic today is going to be regular expressions, which if you have not seen before, it will look scary, but it is not scary. It is just something that takes a little bit of learning, but once you get this down pat, it's almost like the key to automating the mundane and the repetitive, and it gives you a lot of flexibility. And finally, at the end, we're going to look at how to keep track of what happened. Talking a little bit about storage and databases, and just more of how we can make this more from a single use thing to something a little bigger. Before we start diving into this, I want to show you something a little bit more complete of how this thing works for what we're building today. So we've got just a drawing up here of the system's design. It's very simple. We've got network devices. They have some sort of fault that occurs. That fault, such as a link going down, generates a local log message, which then gets sent to a central syslog server. So assuming that the network device is alive enough to send messages to a syslog server, we can at least collect those messages. And using a piece of software that we're writing here called the parser, we can read those log messages in real time and try to decipher on them and see if we can do something about it. For example, parsing out and saying, this is something I can act on, and then running remediation code against that. Or here, the word remediation just simply means trying to fix or troubleshoot the issue. It could be something as simple as shutting down an interface that has CRC errors, which, as you know, are going to cause a bad experience, to something as more complicated as redirecting traffic around a network device, or something more to just add to making your life easier. For example, if you know that this specific log message is symptomatic of a hardware failure, and you know that you normally have to grab, say, 5 or 6 log files and open a vendor support case for that hardware failure, your remediation could just be that. It could be running those show commands, grabbing those files, and creating the vendor support case for you. Okay, so now we're going to jump out to a quick live demo. On the USB keys, that we're going to go into this in a minute, but if you have already gotten a head start, you have what we're showing right now, which is a virtual image that we'll be working with. But for the live demo, I'm just going to type run nanog demo.py to show you a little bit of an insight of what's going on. So if we scroll up a little bit, we see that one of the first things it shows us is new log event found. And so this is reading a file that's staged here to mimic or act like our syslog server. And so we see a log event here that says from 2015, April 2nd, we have this interface removed message, which at the time that I put that together was symptomatic of a module or hardware or a line card failure. The code is trying to decipher and look at these messages and say, do I know about these messages? Do I know what I can act on and what I can try? So for example, it's looking at this ETH port 5 IF down interface removed as the thing to key off of. And it says, hey, I know what that is. I'm going to try to run a remediation for it. And so as we see it, it's trying to look at, for example, module 5, writing like, for example, show uptime. It says module 5 is currently online. Let me check the uptime. So here we see module uptime appears sane. This is just simply the result of this code trying to decipher based on what it saw, whether or not the module actually is problematic of a fault or if it's just a benign failure. For example, we could see a message that is symptomatic of a module rebooting, which might be the case of a chip going bad, and we could just say, how often has it rebooted? Has it been up for a day or a week, or has it been up for like an hour, and then decide from there. So that remediation was really simple. It didn't really do anything. It just simply filtered out and said, this is probably a false positive. I'm not going to take any further action. But the next message is a little bit more useful. The next message is where we see a link going down, symptomatic of potentially a link flat, where we see Ethernet 1/4 went down due to link failure. In our log message, though, if we look at the second message, though, we see that we've detected a link flapping event based on looking at interface resets, the output of show interface, for example, that you might normally troubleshoot as a network engineer. From past experience, we know at Facebook, and you probably know as well, that interface resets could be caused by bad light levels. If that's something you typically look at, let's have our code do that for us and help and detect that. So here, we're actually looking at that, and we're saying, you know what? I think that's the problem. I see light levels of negative 8.84 dBm on this specific interface, which is surprisingly within threshold for that platform or that vendor, but as in our own experience, something that we found is a problem. So in this case, the remediation is trying to troubleshoot based on our experience here and saying, you know, based on this threshold, I'm going to either say it's good or bad. And in this case, I'm saying this is probably a problem. This link should be drained. Its fiber and patch panel ports should be cleaned or replaced. So what's cool here, though, if you start thinking about putting this together, this script is only just printing on screen right now and suggesting ideas. But if you start connecting the dots, think about walking in the morning and having an email sent to you that says, hey, I have all of these links that are potentially bad that I've either shut down already and redirected traffic from, or I think you might want to look at first thing in the morning, as opposed to getting paged by service owners or your users saying, I'm experiencing poor connectivity, which is probably the result of these link flaps. Taking that a step further, looking at how we use this at Facebook, just to give you some ideas, this could then turn into code that triggers emails to the appropriate people that do that. So if you're in a large environment, you might have a colo facility where you need to engage remote hands. Well, you could open a support case with remote hands just simply by opening an email in most cases, and you could have your code do that for you, bypassing that whole step of debugging and chaining and so on. So hopefully that gives you a little bit of a taste of what we're going to dive into. That isn't that complicated, but I just want to give you kind of more of an intro of it. And so now that we've gotten into that, yeah. So this is where we left off with, we had a syslog message that we identified what the problem was. We tried to troubleshoot it. And depending on the case, obviously you have to see these syslog messages enough to know what code to write around them. But after a certain point in time, you start to build up this nice collection of, well, when I see this event, I know I can run these commands, or I do this. And it's basically putting your workflow into code. And finally, we get to the point of having the solution suggested by your code so that you can do cooler things. You can write more code to do other things, or you could go work on the more interesting parts of your day-to-day. So that brings us to our first activity today. We're going to be working with a virtual machine that I just showed you, which has been created using VirtualBox that has basically a lab environment pre-built for us. So you should have already a USB key that we were handing out, one of these potentially. I want to take a minute to make sure that you can get comfortable with this. And so what we've got on here is a virtual machine of Ubuntu desktop. It's been customized a bit with the latest and greatest versions of Python. But granted, today we're not going to show anything that requires absolutely the latest versions of Python, but it is there if you want to experiment. And then we've pre-staged it with a handful of libraries for our work today and tomorrow. If you are attending tomorrow's tutorial, which is going to continue on this, it is the same virtual machine and the same code that we're working with. So I want to walk you through the first lab activity, which is going to be importing the virtual appliance. If you do not have any virtualization software installed, you will find installation files for VirtualBox on the USB key. And you will find the virtual appliance as this devbox01.oba. If you're following along with the webcast, you can also download this from netengcode.com, which is simply a link to a Google Drive folder with all the same files. And so in VirtualBox, once you have that installed, to import this, we simply go to File and Import Appliance. And you'll start to see something like this. I'm going to take a break here for a moment just to make sure everybody gets caught up. I know we gave out these keys ahead of time, but I do want to make sure everybody gets to this point and take a few-minute break. One note, though, if you already have VMware installed, we did test this, and it does import into VMware Fusion on Mac and a likely workstation, so you should not need to reinstall VirtualBox if you already have that. And then we're just going to take a break right there. Once you've gotten to this point where you can start the virtual machine, go ahead and raise your hand so we can get an idea on timing. Cool. And if you get stuck or need any help, feel free to grab. We've got a handful of Facebook helpers around as well. And while we're taking that little break, do we have any questions so far on what I demonstrated? Anything confusing or any questions about what we're going to be going into? Yeah.
So does this mean for different vendors and different devices, you have to accumulate a repository of messages that would potentially flag?
Yeah, so repeating the question for those on the webcast. The question was, for different vendors and different platforms, do you eventually have to build a repository of all the different vendors and the platforms and their log messages? Unfortunately, yes. Tomorrow, we're actually using a piece of code that I wrote as part of the prep called a syslog generator. So if you look in the 201 folder on the USB key, you'll actually see a large collection already of a handful of vendors that I did put together for that demo. The unfortunate side is, yes, as you have more than one platform, you have different log messages. The one nice thing, which I don't know if the vendors meant to do, but a couple of the vendors actually kind of similarly copy each other on their messages. So you will notice some similarities. For example, it's not uncommon for that link failure message that I showed yesterday to be similar or identical across 2 or 3 different vendors, which means that you can get to a point where it's a fuzzy match instead of an exact match based on how we build this. So you won't end up repeating it entirely for each vendor, but you will have to key on some differences, and you will have to write code that handles it slightly differently if it's different vendors. But definitely check out in the example code, the 201 folder, the syslog generator, to get an idea of a large collection of those messages, where I've already broken them out to different vendors. They're not named by vendors, but they are broken out as like vendor 1, vendor 2 to give you some idea of what might be different. Okay, at this point, I'm going to go and continue on because it looks like everybody's gotten pretty comfortable. If you still have questions or you're stuck right now, please raise your hand. We do have plenty of people in the back to help you through this because we're going to be working with this virtual machine throughout the day, so it will be to your advantage to get past this. One note, though, if you do run into an error, there was an issue last year when we gave this where, long story short, the virtual machine is 64-bit based, and in some computers, that requires what's called virtual extensions to be enabled in the BIOS. And there was a handful of people that we had to restart into their BIOS to get that enabled to work. And if you get stuck on that, please grab any of the guys in the blue shirts back there. Oh, and so one thing, the virtual machine is set up to auto log in for you. If you need the credentials, they are just simply demo in lowercase. And it is set up to automatically bring up an IPython terminal for you, should you need it. And then one quick keyboard shortcut to go in and out of full screen. On a Mac, it's Command F. On Windows, this is actually wrong. It's like right, shift, control, and F. It's a long story to get to the Windows one, but that's the keyboard shortcut if you're on a Mac. So that brings us to the beginning of our real content today. So I am going to start out with some basics of Python, hopefully to make sure everybody's on the fair playing field together. So we're going to start out first with just showing IPython, which is something we're going to use throughout the tutorial today, which is a really handy interpreter for Python. So to compare what we're looking at, if we run a normal Python shell just by typing Python, we get a shell that looks like this, which lets us do some simple prototyping without building an actual script, closing that script, or running that script. And just for an example, we could say for I in range. And so it lets us write code just like this. And we can use up arrows and down arrows just like this. But it has some limitations in that if I wanted to write a bunch of code in this shell and just say, look at my history, well, I can't just type history and get my history. I have to go scroll up and back and forth. Likewise, if I want to import something, let's say in the time module, and I say time dot, I'm like, hey, I don't remember what the function is to sleep, which happens to be time dot sleep. There's no tab complete here. So as if you're a beginner or even advanced, IPython is a really nice shell that gives you everything the normal Python shell gives you, but it adds some handy things. For example, you have tab completion. So if we wanted to arbitrarily sleep, and we forgot how to do that, I can just tab complete, and it will finish that for me, which is really nice to avoid having to hop into Stack Overflow and Google and all of that. Likewise, if I type something and I'm like, I just typed for an hour and I finally got something that works, I can actually just type this history word here and get something that I can just copy and paste to an actual script. I just want to show you this because I started the opposite direction where I wrote everything in a script in VM, saved it, closed it, ran it, it crashed, tried again. This is just really handy for saving some time. And so we'll be using that quite a bit today. So jumping back to the slides. So looking now at some of the Python basics. We're going to be working with things called a few things in Python. So looking at, for example, our basic data structures or ways to organize our data, we have things such as lists, strings, tuples, and dictionaries. If you're new to coding, these are some of the most important things to take away from today and to be familiar with because they will help you immensely as you start to learn and go further. So if we start out with something simple like strings, we have, for example, a session from yesterday. Is IPv6 really faster? The text, for example, is IPv6 really faster, is a string here that's assigned to a variable called session1. And we're simply using that saying variable name equals whatever the string is enclosed in either single or double quotes. And so if we continue on that and we want to start building like an agenda, for example, looking at the guidebook app that we had from NANOG, we could start building this list of sessions that we want to attend by creating, for example, using this bracket notation where we create a variable that says my schedule equals open bracket variable 1 comma variable 2. Now I show session 1 and tutorial 1 here, but you could actually put the actual strings there. The point here is you're making a list with multiple elements using these brackets. We have something somewhat similar but different, which is called a tuple. And this is actually corrected from last time in that what creates a tuple is just simply the use of a comma between two things. So if we compare the previous, we have brackets on the outside of these elements. If we remove those brackets and use the exact same thing, we now have a tuple based on just this comma notation. And I only have two things here, but I could have multiple things. Now, this might drive you crazy if you're looking at this and you're like, why do we have two things that are almost identical that are just barely different in syntax? Well, it depends on your use case of why you might use one or the other. So if you're writing code where you want to be able to manage and add or remove things to a list, for example, you're building an agenda, and you want to drag and drop things in and out of the guidebook app. And you say, I want to attend this, but then I change my mind. Well, you can do that with a list. You cannot do that with a tuple, though. Contents of a tuple cannot be changed. You have to destroy and recreate the tuple. So it depends on what you're using it for, whether or not you want the contents to be changeable. And there are some performance aspects to that. And one caveat, and a correction from last time. In previous slides, I mentioned that it was the parentheses that made this tuple, but that's actually not true. It is just the comma. I note this here because this is a really easy way to introduce a bug without realizing it. By accidentally putting trailing commas in your code, you suddenly turn things into tuples without realizing it. So be careful of that. So now looking at something a little bit more advanced. We have dictionaries in Python, which in other languages are called hash tables. It gives us a little bit more flexibility, though, because instead of having a list of one or two elements, we now have a mapping or a searchable index of keys and values, where when we look at the different nanogs that we have, for example, today being the 66 nanog in San Diego, we can assign and search on that using this notation of, for example, 66 as the key, separated by a colon with the value next to it as the string. So what's useful here, though, is with a list, I can't directly say I know this. I want, like, for example, a list is containing one element in each position. But in this, I'm building a searchable method or a searchable container, for example, where I say I want to get the value associated with the nanog that is number 64 here. And I reference that using this bracket notation of bracket 64. So that brings us to our first quick simple lab here. I want you to meet your neighbor next to you and figure out their name. And so try creating a variable with their name as the first item. Then try to create a list of your adjacent neighbors. And then as the next one, try to create a dictionary mapping their last names with their first names. And so we're going to take a quick break. And here's just a little bit of an idea of how to get started. But go ahead and try hyping into IPython and building that just to get familiar here. And so one thing to compare that I didn't quite show on the previous slides of why you might use the list versus dictionaries, for example. So if I want to look through, for example, this list of neighbors, I could say for neighbor in neighbors. So a simple list lets us iterate one by one. But it's not quite that flexible. Whereas with the dictionary of neighbors, I can search specifically by a name if I already have that. Like that. And so with IPython, it's printing me the output here. So this is the same as saying print the result of that. What's nice here, though, is if you have a giant list, let's say you have a large giant chassis switch, and it has 768 interfaces, and you have BGP sessions for every interface. If you put all of those BGP sessions in one list, that's a lot to iterate through if you walk by that one by one. Whereas if you already know those BGP sessions, for example, if you have a session with an IP address of 1.1.1, and you want to associate some data, for example, the route maps in or out, or the prefix counts associated with that, a dictionary here starts to make more sense because then you can quickly search on it without having to walk through everything in that list. Now, granted, a list of 700 items might not sound big, but when you start saying 7,000 items or 1,000,000 items in code, that still becomes quite slow. And you don't want to just have to walk through things just for the purpose of doing it. So we're going to continue on. I'm going to skip the first question section since we're going a little bit slow right now. And so we're going to start diving into a little bit more content. So working with modules in Python. I actually just briefly demonstrated this just without mentioning it, but we were when I was showing you the initial intro to IPython, I was using this thing called the time module. So what is a module? So in Python, a module is simply a collection of files or a subset of files as part of an overall package. For example, we have a module that we'll be using heavily today called the RE module. And so you might see this, or you might have seen this prior with this import statement. And so what's going on here is I'm importing or making available the RE module with this, which is a way to add extra code that's not currently in your code. For example, the RE module gives us regular expression matching, and the time module gives us functions, for example, to arbitrary sleep. Say, for example, if we run a command on a device and we want to wait 10 seconds before running another command, say we want to wait for BGP sessions to come up before we look at them, we can use the sleep module for that. And so this is part of the standard library. And one note here is when you import something, the RE name here is the current module's namespace. That is not necessarily the module, the file name, but it is the namespace in your code. Meaning that if you import RE as something else, you might see this commonly with, for example, the pretty print module, which is commonly shortened to like a couple letters instead. You will see this notation of import something as something else. And so what's going on here is we're importing the module and renaming it as RE module here. And so if we were to access methods from that, we can no longer access it from RE. We would access it from whatever it's renamed to, the RE module. Looking at today, though, we're going to be using heavily, the re.match function, which specifically takes two inputs, a regex and a thing to match against. And if I did not know that, how could I find that out? Well, that's one thing that's quite handy with just Python in general, is that we have built-in help. So if we were to import the RE module, and we know that we want to use re.match, but we don't know how to use it, we don't actually need internet access or Google or any docs to figure that out. We can simply type in help around the method, and it will specifically tell us enough, either documentation internal to the code or generated documentation, such as what inputs it requires. Such, for example, the first input is a pattern, and the second input is a string. But if we did not even know that, we could simply type help around RE, the module, and start to browse what methods it has available, just to get an idea of what we can get. We'll get any documentation already described, and then as we scroll through it, you can start to see different methods in here. Now, this can be a little bit complicated to look through because it has quite a number of methods. But specifically, we will be using re.match, which simply takes in two things. a regex and a thing to match against. It's going to return one of two things as well. Either none, saying I did not match anything, or what's called a match object, which gives us more data about what it matched. So I want you to actually try this out real quick, just to become familiar. Specifically, I want you to try typing re.match eth out of Ethernet. And become familiar with what it gives you back. And so you can, if you just hit enter, you should see back something like this, where it just says SRE match object. It's kind of fuzzy looking at that, and you're not quite sure what it says, but that simply means it did match. And so what we could do is assign the output of that to, let's say, a new variable. For example, matched equals. And this is where the help comes in handy, because now we can start introspecting what things we have available from that match object, for example. For example, we have match.group, which lets us specify group numbers if we start using groups, which we're going to get into in a bit. Yeah. In this case, we didn't actually use group symbol, so there is no group, but you start to get a little bit of an idea there. So if we jump back into our content here, actually, before we continue, do we have any questions so far? Okay, cool. So now we've gotten some of the basics of Python out of the way. We've gotten a little bit familiar with strings, lists, tuples, and dictionaries, and also the idea of modules. So now let's take a look at actually putting this to use. So I mentioned in our demo earlier, we're building this system, what we use at FBAR or at Facebook is based on syslog parsing. So we have all of our devices sending messages to central syslog servers, and so we need to parse those messages either centrally or in a distributed manner. So here, if we start looking at this, we're going to bring back our friendly variables again. And so we have a file already staged in this VM called syslog.txt that has those two log messages already. And so here, if we want to start opening that file, we're going to create a variable of the file first to say syslog.txt and basically give it the file path. We're going to use this with statement to say with open, and the first argument here is the file name or file path, followed by the mode, such as reading or read-only or potentially writing. And then we're going to use this as statement to say what is the name or the reference to this file. So when we open this file using with open, we get back what's called a file handle. We haven't directly read the file yet, so we don't have the data from it. But we have a pointer or a file handle to the file. And that's represented by this variable called syslog. With Python, we have a method called readLines that lets us turn an arbitrary file into a list of lines, like this. And so if we go into our next lab, let's go and walk through this together, where we're going to open this file and try to parse it. But first, I'm just going to show you that there's nothing fake here. In the current working directory, I'm going to cat syslog.txt. And here you see the two log messages that we started with. So if we go back into IPython, to open that file, we simply just use this with statement, with open. And I actually used a variable earlier. I showed you that more so that you have an idea that you could. You don't actually need to. You could just specify the file right here directly. So syslog.txt. And then the second input is the mode. So lowercase r for read-only, or W if you wanted to overwrite it, which I would avoid because that's going to wipe out the file for you. But WR will open in read-only, which allows you to make sure that you don't accidentally overwrite this. And then we use as to rename or point this to a variable. And so if we were to just say print syslog, I just want to give you an idea of what that is. So it's not directly a string yet. It is just this object representing the file and pointing us to it. And you notice I'm using this with statement, with open. This may also look familiar as something like this, f equals open syslog.txt. So the two, just to compare the two, I'm using this with statement because it actually handles cleanup for me. In that when I'm done reading the file, I need to close the file. And if I forget to close the file, I have what's called a stale file handle open, which in one script is not a big deal, but if you're running something long-lived, that leads to memory leaks and problems in production. So if you use with open, it makes it a little bit cleaner for you because it's going to handle closing it for you. So right now, I should still have syslog. So if I use read lines off of that, it's actually yelling at me because I'm trying to read it after I closed it, meaning the outside of the with statement. So if I just use scroll up to bring that back and say, and now I'm just going to create a new variable, log lines equals the result of calling syslog.readlines. It's still printed because I had the print statement up earlier, but now if I look at log lines, I have a list of lines from that log file. It's pretty simple, but it's just something nice. Because now at this point, I've read the log file in, and if I print, for example, length of this list, I can see I do, in fact, have two elements in that list, two lines representing each log event. So if I wanted to start walking through this, I could just say for log in log lines, print log. So that's cool, but not really, because all I've done at this point is build cat in Python. But I'm trying to give you an idea right now of at least getting the file into memory, starting to look at it so we can start digesting on it and start doing things with it. So if we look back now at trying to parse this, that's where this starts becoming interesting. And we're going to walk through at this point now and parsing an example message from a network device. Let's say we have this message of IF down, interface remove, something like this. This might look familiar for, if you're running any of the network devices out there, just a standard message that I found in show log, for example. So the one key takeaway, I'm going to start walking you through how to parse this, but the one key takeaway I want you to know is that you want to build code that does not need to be an exact match of what you've seen. For example, this says interface Ethernet 5/1 is down. Interface and Ethernet are uppercase right now. As I start to build code here, I want to make sure that I don't care about whether or not the case is uppercase or lowercase. Because surprisingly, vendors have changed the casing throughout different versions of their own code, which is a really annoying thing to have to fix. But you can write your code a little bit smarter that way and not have to think about that. But first, we need to think about how to parse this. And if you've tried regular expressions before, or if you're familiar already, you might realize that this is probably a pretty long regex if it's one of your first ones. But we can make that easier. We can start to look at this with an abstract lens first. And so I want you to look at this and start breaking it up into pieces and start thinking about just matching individual pieces first. So what I have highlighted here is 2015, April 2nd, just the date of the initial part. And so I'm just going to replace that with the word date stamp here to represent what it is in my mind right now. The same for the next one, which is the time. I'll just call that a timestamp. And as we walk through this, we just replace each piece of this. And so, for example, the thing I keyed off of earlier, IF down interface removed, I'm renaming this to just error code. Either error code or error category, whatever makes sense to me. And then the final piece is more of what I would say is a human-friendly message that is just meant to make you feel good when you read show log. So let's just call it that, error message. Now let's take a look at turning that into what we want to call structured data, which is how our code needs to see it to be useful to act on it. Because we were going from one log message. To actually run code against that device, we need to know what device that is. We also need to know what that error code was without having to reparse all this over and over. So to take a look at turning this into structured data, sometimes a block diagram comes in handy. But this is, again, just showing you a visual representation of what I was highlighting just a moment ago. OK, so I just gave away the secret of what I was about to go into. But what is the key to going from text to structured data? Well, that brings in our friend regular expressions. And it's simply a way to ask, does this pattern exist in a given block of text? where this pattern is just something that has been created by you. You might also hear this referred to as building a regex. And so if you're familiar with BGP and writing AS path filtering lists, you've already seen regular expressions in at least a simple form. One I've got right here, AS path access list 1. I'm matching on caret $sign. And if you're familiar with that, it simply says I'm matching on beginning of line followed by exactly end of line. In other words, an empty line, meaning that I don't want anything that has an AS path already in it. So that is already a regular expression right there. And so now let's take a look at it, starting to apply this with Python. So we're going to walk through this actually a little bit live as well. So we're going to build just a regular expression for the first thing. For example, matching that date stamp, 2015, June 2nd, for example. Or in this case of today, we're on the 9th of February. So let's just walk through this. So let's say today is Feb 2016, Feb 9. And if you're in IPython, try to follow along. We're going to walk through this piece by piece. We're also going to import the RE module. Excuse me. And so now what we want to do is build our regular expression. So looking at this, I'm going to create a new variable called date RE, for example. And it's simply a string here. And you might have noticed something different. I'm putting a little r in front of the string to say this is a raw string, which tells Python to not try to interpret it or think about it too much. And so now, looking at the pieces, we want to start matching on this 2016 here. We could actually do an exact match and type 2016. And that is a valid regex. That would match only 2016. But that's not too useful when the year becomes 2017. What we want to do is we want this to be dynamic. So in Python, we use this backslash notation to say a special character is going to follow after this. And specifically, when we want to match on digits, such as 2016 or the 2, we use a D here. So /D is going to match on exactly one number right now. That's cool, but not really. So we want to match on the whole year, though. So if we add a plus, that's going to say one or more of the prior thing. So that's going to repeat one or more of /D until I get to something that's not a digit. So at this point, /D plus is going to match on 2016. And we can actually see that in action real quick. So if we say re.match, date re hyphen today, we see that it did successfully match 2016 out, only 2016 out of that string by accessing the result of .group 0 off of the matched return. And so as we start to build this, we still want to match the whole thing out of this. So to match on the space, we would use a different character, /s. Or to be a little bit more dynamic or less error prone, I would use actually s plus here. So even though I only have one space, that will catch us if we have two spaces or three spaces. This is something back to the comment earlier where two vendors might be almost identical but slightly different in that they might just add more spaces or less spaces, and this becomes a little bit more generic that way. Because even though we only have one, it will stop matching after it changes to something different. Because once it hits the F, that's not a space anymore. And so to match on Feb now, we would use /W here, or /W plus, which is going to say one or more characters, which would match on the FEB, but stop when it hits the space. And then to match again in the space and the 09, it's just repeating. /S plus would be this part, and /D plus would be the end of it. And so if we try this again, we now matched successfully the whole thing out of that thing, which is cool, because now we're starting to get pieces of this. For everybody following along, did you successfully get to that point where you were able to match out the actual date from it? Cool. So one thing to note, though, if my date looks something different in that today was NANOG 66, like that, where I had other text in front of it, 2016 Feb 09, that match will now fail. And I can no longer access .group0 because it is actually a none response. So what changed here, though, is that I have other text before the digits. So if I look at date RE, this is an exact match based on the start of the line or the start of the string. So to look at other things or to ignore other things, I would have to specify that in my regex. It's something to think about. And we're actually going to dive into that. And all of what I just walked through is on the slides. So if you notice I'm jumping slides, it's only because I have extra slides as reference there. But they're exactly what I just showed you. Yeah. Cool. So to finish out that thought, though, to ignore the other stuff, for example, we have NANOG 66 here. We could slightly change our date stamp RE to say date RE equals. So dot will match on one of anything. And we could say dot plus and basically throw that away using these grouping symbols. And then using the grouping symbols or parentheses, we can say, here's the regex I actually care about. And then we could just repeat what we had before, /d plus to grab the 2016, /s plus to grab the space, /w plus to grab Feb, and so on. Oh, actually, I screwed that one up. Oh, I'm sorry. So this is a good screw up here to show you live. So I'm screwing this up because I'm still printing group 0. When you start to use grouping symbols, group 0 is the entire thing regardless of the grouping symbols. Because I added parentheses, I now have group 1, which is what I actually care about. And so this is actually group 1 now instead of group 0. And so if I print group 1, I should get back what I really cared about. So if I fix that again and take away the 6 here, that should still work. Not quite. You get the idea there, though. So regular expressions are a nice thing to play with, though. So depending on what strings are before that, it may change how you build what you match on. You may want to match on exact, may not. But that gives you some food for thought there. So now let's go into actually parsing some syslog messages. So again, we have this giant thing that we want to parse on. So to start building this together, we want to parse on the date stamp. So what we just walked through, for example, is parsing this date stamp as /d plus, which is one or more digits, /s plus for one or more spaces, /w plus for one or more characters, and so on. So now looking at the host name, though. We have lots of host name formats at Facebook, and it's almost a nightmare to look at how many different ways you can build a regex around different formats. For example, our more newer network design, the Fabric, includes a much longer host name scheme where we have like F01, SSW01, Spine 1. It's like 5 sections long now. One way to build that regex is to actually break all those into sections and add to it. But I wanted to give you an example or food for thought here of what if you don't really care about what that hostname scheme is. Other than that, you want something that's probably a valid DNS name. So if I use a capital S here, so /s plus, that's going to match in Python on anything that's not a space. Which means that if I have switch1.example.com, I'll match it with this. Or if I have our crazy names at Facebook, it'll also match. That gives you a way to make your life a little bit easier and not have to dive deep into it. Again, that's instead of a small s for spaces, this is a capital S now. And so looking at the next part, the error code, this is where I'm using those grouping symbols to my advantage to say match exactly on that % sign at the beginning of this, but throw it away because I have it outside of the parentheses. And then again, I'm using the same /s plus to say match on anything that's not a space, followed by the colon as an exact match to use to help me throw away this. Now again, back to the comment earlier, this is where if you have 2 different platforms that put messages in different orders, you would obviously need to build a different set of regular expressions for each platform, especially if you start adding servers into the mix. But once you get one down, though, it's a lot easier to add the next one. And so looking at the message now, the error message, interface 5/1 is down, we can simply match this using what's called a greedy match, meaning that we know that the rest of the line in this log line is a string that represents this error message. And we have no more data to care about after it. So we can just simply match on dot star here to say match on anything until the end. And that will assign all of that, which is kind of handy because now you don't have to think so much about it. And so if we look at this, what we just built as we walk through these slides are a separate regex for each piece. And then finally at the end, I have one called column delimiter for the /s+ between the sections. When you look at something that's really complicated and you want to build a regex around it, one good example that comes to mind is the output of show IP BGP summary, which is a great thing to build regexes against because you can get a lot of data from that. But it can become quite cumbersome to build that regex. So if you break it into pieces and test each piece separately, you can start adding to it together. For example, these are all strings right now, in that each regex is a string. I just have all these variables representing them. So with Python, I can combine strings using standard string notation. For example, this plus sign will allow me to put 2 or more strings together. So what I'm doing is I'm actually just creating one regex that is the whole line based on all of these regexes combined. And this just makes it a little bit easier on the eyes as you start to look at it. It also gives you a way to start testing this because then you could test each piece as you build to it. So you could have the full log line, but then test until you get to, for example, device name. Once that works, add the next. And then that way as it breaks, you know where it breaks. OK, so let's get on to the exciting part of actually matching out this data. Because what we want to get is data from these syslog messages so that we can actually act on them. So if we start walking through this, we can, yeah. So if we start walking through this, we have log lines in memory right now. So if we walk through 4 line in log lines, now that we have our regex in memory is actually, so to save you some time from all this typing, that regex, the full one, is actually in your Python memory right now. So if you were to type syslog_re, all caps, you'll see the full regex on the prior slide, which lets you avoid having to retype it. So if we walk through this 4 line in log lines, we can say m, which a new variable to represent the match return, equals re.match, and we'll say syslog re, which is our regex, against the line. If m, we could say print m.groups. And so as we walk through this and see this, we walk through each log line, we try to regular expression match, and then one note, we added some safety to our code because if it fails to match, we only get back what's called a none response. A none response will not have a method called .groups, which means if you try to call .groups, your code will crash if it fails to match. So you want to sanity check that before trying to access that. But here, what we get back now is our friend a tuple. We get back a tuple of the different attributes that matched. For example, the first piece was the year and the month, followed by the time, the host name, the error code, and the error message here. That's kind of cool because now we start to get at least the individual pieces that we can start interacting with and start trying to do things against. And one other note here, though. So I mentioned we're using grouping symbols. So when we call .groups, we get back the return of all groups that matched. If we called 0, we get back everything that matched as well. But if we call back one group in specific, if we call back .group and not groups, then we start getting back the individual sections of what matched. So for example, 2 is the date, and then for example, 3 here is the device name. This way you can start looking at it and assigning variables potentially to these. You could also do something like this, where you could say date, comma, timestamp, comma, device, comma, error code, comma, error message equals the result of m.groups. And so what I'm doing there is I'm assigning the values of m.groups, which returns a tuple, into direct variables here. So now I'm just extracting it on the fly to individual variables, so I no longer have to deal with the tuples directly. And then I can just act on the different pieces of those tuples, for example, device and error code. Cool. If you were following along, did anybody have trouble with that piece of it? If you didn't get a chance, go ahead and try it, though, just to get an idea of how this is going to work. And before we continue, do we have any questions right now? Yeah.
Can you see the regex components that make up syslog _re, the name of the regex components?
I think, let me see. I'm not sure if IPython, it should show you that. If not, offhand, I'm not familiar or not thinking clearly right now. But if you exit out of IPython and look at the file called nanogdemo.py, you'll see them directly there. And I think, let me actually take a look at it, because the way I'm preloading that is under this profile thing. It might actually be in there. Oh, yeah, so you can see the individual components. So what I'm looking at right now is actually the file I'm using to preload this into IPython, which is under .ipython. Well, it's a long name, but basically if you type in uppercase those same names that I showed on the slides, it should print you the exact thing. So if you type in datestamp _re, you should see just that portion, similar to this. Yeah. So using the same names, it is showing it slightly different. So if you just do, I think, print, it should show it correctly. Yeah, if you use just print around it, it'll show you correctly. When you just type it, it's doing some interesting notation from IPython here. Cool. So now let's take a look at building our first remediation, because this is ideally what you actually came here for, to start writing code to do some of this initial troubleshooting for you. Which is going to be based on regular expressions, but based on also some other things that we're going to be using to interact with the network devices to help save us some time. So let's look at our first remediation. When I was putting these slides together originally last summer, the device I was looking at actually I was arbitrarily looking at network devices with show log to say what was the recent events on these devices to get an idea of what might be good examples to repro from. And one I had actually was a device where I had an interface or a module that had failed and was subsequently replaced later on. And what was interesting in that case was I didn't have a log message that said this interface or this module is bad. I actually had 48 log messages that said suddenly all of these interfaces were removed because the module went crazy and did a power reset on its own, which is why in the original example I was looking at uptime. And so if we use that example where we had a message that says interface removed, this is an example where it might be a false positive, but it could be symptomatic of this line card resetting, because people might remove optics to replace them out of normal cases as well. So if we look at this one, coming back to what we just did, where we extracted back the variables from match.groups. A simple way to look at this is we could say if this error code is in this error, or this specific string is in this error code, we can start thinking about how to act on it. Now, one comment here. I am showing, just to keep the slides simple, the casing in uppercase. But when you start to write code, you want to avoid having to think about case. So for example, a way to make this slide a little bit more friendly in real life is you could say if if down interface removed in error code dot, and then use what's called dot lower, which is a built-in method on any string in Python that automatically just turns it into lowercase so that you're always using lowercase against lowercase and not having to think about it. Or uppercase against uppercase. It's just one way to keep your code keep your code a little bit more flexible as things change. But looking back at that slide, though, the simple way to build this remediation is we could just start walking through and trying to do a simple match of if these error codes we know of exist in this, let's do something. So for example, our first message here could just be a print statement of, I found a known error. At least I know something about this because you told me about it. Granted, this goes back to you have to know about these error messages, but over time, as you build a collection of them, that just kind of comes. So looking at this one in specific, what we now need is more data about this. So in this log message, we have Ethernet 5/1 is down. If I'm building this message around the assumption that this might represent a module going down, I need to figure out what the module is, which is where we bring back our friend regular expressions. Using something like this, where I say I want to match on the 5/1, or more specifically, the 5 out of this. And so I can do that using code like this, where I say interface equals the result of arg.match, and I have to throw away the other parts of the text now and just look at the 5/1. And so here, we're using something different, though, in that we used backslashes earlier. Actually, okay. And so we used backslashes earlier. So if we have something like this, for example, we want to match on just the 5 out of this and and ignore the rest. So what we could do is arg.match on that and say /d plus followed by a /, which is not a pattern matching symbol. That's an exact / now, /d plus. That would actually match on both 5/1. But what we really want in this case is the module number, and we want to throw away the other part of it. So one way to do that, though, is we could just match on the whole thing and then use, there's two ways we could submatch, for example, out of actually, I screwed that up. Hold on. Oh, so again, this goes back to the fact that it's going to match on the beginning, so we need to throw away the other text before that, and then now we should be able to match. So in this case, we have 5/1 as part of the first part of the match, and so what we could do, 5/1. So what we could do, this is common to see something like this, where we say interface equals that, and then we could call something called .split and say interface .split and split in Python on the /, which gives us a list of the two things now, before we split and after we split. I would actually caution you against using .split here because you can make your code, because that leads to code like this where we start directly accessing the results of that. So for example, that gives us back a list. And the first thing in the list is what we care about, this module 5. And so what we want to get back is something like that, where it's module 5 equals only the first thing. The problem here is that there isn't a problem right now because that worked. But if my split failed and I start trying to access positions of lists that don't exist, then you have to think about a code that's going to crash now. Because if you try to access, for example, position 6 that does not exist, you get a traceback like this. And since I'm in IPython, my code hasn't crashed. But in real life, this code would just crash and stop running. That's where just making your regex a little bit smarter so that you can avoid .split will help you. For example, just moving the parentheses here. And now we have m.group1. And so now we just have the module number equals module 5. And so let's look at actually a real device to kind of put this in perspective. I should still have my SSH connection up. No. But I still have VPN up. So I'm going to just show you actually the device I was building this example from to give you kind of an idea of what I'm looking at as we start to build this code. So for example, we have this cluster switch out in one of our Sweden data centers that had an issue with module 5 at one point. So if I just, for example, do show module, I get back, for example, the modules and the status codes. And so one thing I can look at is whether or not that status code is OK or if it's failed or not. As we start to look at our remediation here, that's what our remediation is going to do next for us. So as a human, as a network engineer, if I see, for example, a message that makes me suspect this module, I'm going to look at show module and I'm going to say, is it OK, or is it offline, or some sort of error condition? So we could do, for example, show module 5 here and get back the same data. So in our remediation, we can start acting on that. And so here, now we've gotten module 5 at this point. So what you see here is I'm building in code the command of show module 5, which I just typed on the console. So what we want to do now, though, actually, before we continue, I do want to make sure that you are familiar with this piece of it. So if you haven't followed along already, go ahead and try to build a quick regex to parse out 5 from just Ethernet 5/1. If you get stuck, please raise your hand, because I do want to make sure that we help you through this part, so that way it sets in and it becomes like second nature for you. And once you parse that out, we're going to start using these commands with SSH to and from these network devices. And so if you haven't seen this before, one handy way to put variables in the middle of a string with Python is simply this thing called .format. So if I want to say my command equals show module and then the number, like I just issued on the actual device, I can use this notation of the curly braces, which look like dictionary symbols, but when they're used in the middle of a string, they're actually used as part of string substitution. And I can say .format as part of the end of the string and pass in something to substitute in there for me. So in this case, I can pass in module, which we see up here is should be this number 5. And so if I print command, I should now have show module 5. Cool. So now I have a command I can legitimately run against this network device, just like I did on my SSH terminal. And so to do that, we're going to start using SSH with network devices. And this might spark some questions in your mind, because a lot of vendors now support newer methods to talk to network devices, such as these different APIs, XML collections, or, for example, all kinds of ways. I'm going to show you just SSH here, because I want you to walk away with something that should work on most of your devices, regardless of what code version you have, because I assume that you're running at least a new enough code to run SSH. If you're still writing Telnet, I strongly suggest going away from Telnet. But SSH is not an evil thing to write code around, because at least you know that whatever you can run yourself with SSH to debug, you can then write code to do it. Whereas comparing with some of the new APIs that vendors have out there, we actually haven't used those nearly as much as you might expect at Facebook on the vendor platforms, because what we found is that most of the commands we actually want to run are not yet exposed, or they don't expose enough. For example, in a real-life network, you might want to grab things such as deep level counters off the individual ASICs or the individual fib tables off the cards. A lot of the APIs may expose that or may not. And in the case of this, with SSH, you know at least for sure if you can run the command over SSH and you can hop in that, for example, remote session command, you can grab the same data. So here, let's take a look at using this with SSH. We have a module called SSH helper in this VM that is simply a wrapper around something called paramiko. And so we use this by saying import SSH helper. And when I say it's a wrapper around paramiko, I actually had a lot of trouble when I first started trying to learn paramiko, which is a native implementation of SSH with Python. In Python, there's a couple of ways you can do this. You could call to the underlying host or the shell and run SSH and interact as a shell session. Or you could open it natively. So paramiko is a way to do it natively, which I had a lot of trouble initially, and so I built this module just simply to make it a little bit simpler in terms of handling some of the basic setup that we use. It's actually modeled after the telnet module, if you're familiar with Python's telnet module, which has a very simple, clean interface. And so if you were to take this code and run it outside of this VM, you might see an error message like this, for example. And what this is telling you is that you do not have the paramiko module installed, which is a separate third-party installation. So if you don't have that, you can install that on Ubuntu with this thing called pip, sudo pip install paramiko. If you're on a Mac or other things, it's just simply a download and something to install. But I'm putting these slides here so that you're aware of it in case you run into those problems. But it is pretty straightforward. Excuse me. So sending commands over SSH now. So I actually mocked this up a little bit so that we can actually interact with this module, even though we may not be talking to this network device. So to open an SSH connection to it, we simply in the IPython terminal can write import SSH helper. And you can definitely follow along on this. Even though I have VPN up right now, I'm not going to connect to the real device. This actually has some mocking built in, so it will actually give you real output when you connect to it. So if you import SSH helper, we're going to open an SSH connection like this. We're going to say SSH equals SSH helper dot. And this is where tab completion comes in handy, because I can just start typing the name of the object that we're going to use to represent this connection and hit tab, and it'll fill it out for us. It's going to take in 3 inputs at minimum: a device name, a username, and a password. Because of the mocking that I'm doing for this demo, you can give it actually any data for those 3 inputs, but it's going to want something. So we can just say switch 1, demo, and demo. And if you're following along, try that as well, because this should still work for you. So at this point, if we were using this on a real network device, we would actually have the underlying TCP connection open for the SSH connection. And if we were to just hit enter against that, we just see back basically an object representing this. But what's handy to know, if you look at this, you can again use that help command to say, hey, what methods exist, for example. And look, I have a method called write. It takes in a list of commands. That might come in handy here. So let's try inspecting some output. And so what we ran on the actual terminal earlier was show module 5, for example. And what I'm looking at as potentially a network engineer is I'm trying to see, is the module up right now? And I might actually want to look at uptime, for example. But let's first see whether or not it is currently up. And so going back to this, I have my command already in memory, show module 5. And so I want to get the output back from this. So output equals ssh.write. And it actually accepts a list of commands, so I'm going to put that one command into a list here, like so. And it's going to try to run this command for me. And if I print output, you should actually get back some legitimate output here, so that we can now prototype against. Now, this output's a little different from what I showed you because it's already been staged, but we get back output that looks somewhat similar. And if I were to scroll down or make this small, for a line in output, print line, that should make it a little more familiar. So that starts to look familiar now, where we have a module number 5, these ports, and a status message. So in terms of writing code, what we want to start inspecting is whether or not this module is currently online. So what we could say is online equals false as we start to build this for line in output if OK. And here we can actually just simply, instead of using a giant regular expression, because that's a lot to look at, we could simply just check to see if the word OK is in that output. We could just like this, for if OK in line, set online equals true. So this is not much code right now, but this should actually give us enough to say this module is online or not based on just inspecting the output for us. So if we print online, it is currently true. Cool, so that at least saves us one step. As a network engineer, we now know that we got this message, we logged in, we hit show module, it is currently okay. Let's start debugging it some more. For example, I might want to say, it may be online right now, but it might be rebooting every 5 minutes, for example, which is not all that uncommon for faulty hardware. So one way to look at that is we could do something like show module uptime. So on this platform in specific, I can do show module 5. But you can tell that it's not meant for automation, and it's meant for humans because show module 5 does not give me uptime. But I also have show module uptime, which does not accept a specific module. This is where writing code comes in handy because I can write show module uptime, but now I'm looking at all the modules. So this is something where you can actually start using some of the stuff that you have on Box to kind of help you. For example, this platform actually has grep and egrep on the actual network switch. So I can use that to my advantage here because I really care about module 5. And while I could use my code to decipher and build the equivalent of grep in my code, I would rather avoid that if I can. So for example, I can pipe show module 5 to egrep here and key off of module 5, which I see right here. And I really want the line after that, for example. So if I egrep off of module 5, that's not going to help me right away because that's just going to show me the header. Cool. So now I still have no uptime. But using egrep, I can say after that, grab 3 lines. OK, so now I've built the equivalent of show module 5 uptime because this platform forgot to implement that. So what I can use now is I can have my code go run this. So for example, I can just grab this output and then decipher on how long it's been up. So in this case, it's been up for 204 days. But if I saw that it was only up for an hour, I might say, you know, this is potentially suspect. It could be up for an hour because somebody just replaced it. But if it's been up for an hour every time I see this log message, well, maybe it's rebooting itself or something's going wrong. So let's take a look at building the code to start running that now. Cool. So now we just simply change our command a little bit. Command equals. And this is where the command's starting to get a little longer than what's going to fit on one line. So this is where it comes in handy in Python to start wrapping the lines. And so with strings like this, you can use parentheses arbitrarily to say this is going to be more than one line. And then it'll just let you start wrapping to the next line a little bit more easily. So here we want to say show module 5. Or actually, we're going to show module uptime because it does not, we can't look at that for module 5. And then what we could do now is say show module uptime. And I'm actually just going to wrap the line real quick. Show module uptime with a pipe to egrep. -a, grab the 3 lines after what I'm going to grep for. And say module. And then here is where I'm going to substitute in the number. And one thing you might notice, since on the box, I had to put this command into quotes because it's module space 5. If I use single quotes for my string in Python, then I can freely use double quotes or like the double quotes inside it. And vice versa, you can flip the other way around. That way you don't have to do anything special, and it will allow that. So now we also want to add the module into that. So if I print command, I should have exactly what I just typed by hand. So now I should be able to run that against the network device and say output equals ssh.write command. And hopefully we get back something that looks like what we looked at. Print output. Cool. So that starts to look familiar. And you notice when I print just the result of this, it looks all jumbled up because the return is a list. It's not meant to be human formatted. So to make it human friendly, we could just walk through that for line and output. Print line, and then that should look just like what we looked at. So that starts to become a little bit more handy. So now, and this is kind of starting to walk to the end of that first. If we run again what we initially opened with, NANOG demo.py, This starts to get to the end of the log message, the last log message, where we say, go scroll it. Where we say module is currently online, checking uptime. Module uptime appears sustained. So this is where we can start writing some code to parse out that uptime. It's to say, okay, so we have 45 days. And we could key off of, for example, this first line. This is uptime. Now, again, this is where different platforms, you're going to need different code and different branching to say, if this is vendor X, do this, or if this is vendor Y, do something else. But you can start to key off of this and maybe normalize this data and start to inspect it. So here we see 45 days. That's probably not a problem at this point, because if it's been up for 45 days, it's not rebooting every hour like we may have suspected. But if we saw that this was rebooting every hour, we could then grab more data. For example, the equivalent of like the show tech from the module, or more detail about it, and then just simply put that somewhere to save you some time. Cool. Do we have any questions so far? Does this start to spark maybe a little bit of interest? I know it's starting to, and so we're getting toward the end of the first section here, almost at 11. So we are going to break, actually. But what I'm trying to get at is that it's not a lot of code that we're building here. But it's kind of cool to think about where you can write code to do what you normally type and just interact as if it's you. And you can, as you start to build this collection, you can start automating basically anything that's annoying to you or taking up time that you really don't want to deal with. For example, giving you some more examples of how we use this. And we're going to go in the second half deeper into this with more depth on another one or two. But giving you some examples, if you always know that CRC errors cause problems to your traffic on an interface, you might as well have your code just take the traffic off the interface. And hopefully your network's built big enough to allow you to take that off for maybe an hour or the day that it might take to get that interface fixed, versus being paged at 2 in the morning. And the same as the equivalent of this hardware that fails. I remember in a former job where I would literally do mass deployments, and we would go through 5 to 10 line cards that would fail in a given deployment. And you would literally spend half a day opening like support cases with vendors and saying, here's all the logs, here's a card that keeps rebooting, here's all the logs for this, here's the card, please ship it to here. And it would just be ping-ponging back and forth. Whereas at Facebook now, we use this kind of code to open those vendor cases for us and then automatically just bypass the whole workflow. The same with like links and all that. But we are going to break at this point. But if you have any questions, actually, before we break, one thing I almost forgot, we have some prizes, actually, to keep this exciting. So if you look on the back of your USB key, 10 of these have been marked already with a silver dot randomly. Take a look at it. If you have a silver dot, we have some books to give you away. So if you have a silver dot, come on up here to the front. We're giving away, in today's session, the Python Standard Library by Doug Hellman, which is an awesome author who writes, it's called Python Module of the Week. And be sure to also come tomorrow, because we're giving out a different book at tomorrow's session. But yes, if you have a silver dot on the back of your USB key, 10 from just the batch given out today should be marked with a giant silver dot. Come on over for a book. And then we're going to break now, and then we'll be back after the break to continue building. Also tomorrow, so I know this is a very basic tutorial, but tomorrow we'll go into a bit more depth. Tomorrow is the idea of building the system in the 201 class, which is where we're going to continue building more of the framework around it and not the individual problem and break fix. Oh, cool. Yeah, hold up the books. So these are the books. If you've got a USB key that's marked, go and grab a book up front here. And then also something else, just food for thought, general announcement. We have a Facebook group called Netops Coding. Feel free to join. It's more to have discussion ongoing about this whole like building FBAR in the open kind of thing. But what we're thinking about for next year is, next NANOG, the Chicago one, is pitching the idea of a hackathon, which if anybody here is from NANOG, we haven't actually talked to you yet. But we're basically trying to get feedback for this. If we were to do a hackathon where we build some big project together, there's a poll on Facebook/group/Netops Code of what day might work for you. We're thinking of either a half day or a full day thing where we just try to build something more complete. Because obviously here we can only go through snippets of code, but thinking about more of building a full tool. But with that, we're going to break at this point, and then we'll be back in half an hour. Thank you.